Hello, my name is Alex Kluwer. In this video I'm going to be discussing mode conversion with respect to differential pairs. So I have an LTSpice simulation. So first we have this section over here. So this is our differential mode source. So we have a pulse where half of the signal is on one line and the other half is on the other. And then we have a output impedance matched to the differential mode impedance of the line. So this will be like, it'll be half of what the specification says. So if it's a differential mode impedance of like 90 ohms, these resistors will be 45 ohms. And then we have our two transmission lines, which models our differential pair. So we showed in the other video that the solution for a coupled line or two coupled lines goes to a single line, but the characteristic impedance is replaced by the differential mode impedance. The propagation time is replaced by a differential propagation time, and then the incident voltage is replaced by that differential mode voltage. So we then have our two terminating resistors, which are just like the source resistors, and we have this single-ended transmission line attached to one, and this will model the length mismatch of the differential pair. And we are assuming a loose coupled case, so we can assume that the differential mode impedance, the common mode impedance, and the characteristic impedance are all the same, and then we can assume that the differential mode propagation time, the common mode propagation time, and the regular propagation time are the same. So we have a simulation, and we basically measure from this point to this point and we get the blue line, and we measure from this point to this point and get the orange line. And we can see that what happens is that one of these waves, so if we look here, so we have this wave and then we have this wave, which is the negative. And what happens is that you have, whoops, I need to delete this. You have one of those waves come through, and it comes at a later time than the other wave. And what happens is that you get this weird staircase effect. And this becomes both a differential mode signal and a common mode signal. So it isn't purely differential mode anymore. It has some common mode part to it. And that's called mode conversion.